So this is a YouTube video that we're doing to demonstrate the features and benefits of the ACE Mini Pack semi-instantaneous on-demand steam water heater that was sold at Colby College, one of several. The last job, the one we're specifically addressing for the contractor and for Johnson & Jordan, our customer, is the Colby Athletic Center, which was commissioned this past March of 2020. We started 3 heaters. Everything worked well. This is a customer in service YouTube for the Colby staff, for the general contractor, for the mechanical contractor, for the commissioning agent. Colby has been a user of ACE for 20 plus years, excellent customer. I believe they're satisfied with the product. If not, I need to know that, but so far so good. I believe Tom Mayo and his staff, Tony Toole, have familiarized themselves with this product, been exceptionally trouble-free. There's been some issues we're going to address today, but what we want to do is first go through the overall what we have here, primarily for any new hires that will be on Colby's staff, and then for it doesn't hurt for the existing maintenance folks to hear some of the features and benefits of the Mini Pack. This heater's been manufactured for 50 years or so, Southern California. It's what they call an on-demand heater. It's not a storage device. It's not a direct fired device. It is an indirect, on-demand, in this case steam, semi-instantaneous. We're going to talk about what that means. But it needs either steam or boiler water from another source, and this is basically just a heat exchanger. Okay, we're putting primary boiler steam into the tube bundle, and we're making hot water. Cold domestic water comes into this connection. Hot domestic water comes out of this connection. And it's basically a U-tube type heat exchanger in the shell. These can be offered either vertically, as you see here, or horizontal. They're made in several sizes. The sizes we sold at the Athletic Center, there's 3 heaters, 2 of which are for domestic water. They're model SI-V8 SW SE 250-D. And what that means is it's SI is semi-instantaneous, V is for vertical, 8 is for the diameter of the shell, SW means single wall. The tubing, the U-tube here, the copper tubes, are single wall versus double wall. Dash SE, the S means steam, the E means electronic fail-safe actuation, an electronic NEMA 1 or 4 control panel. And the dash D means a double solenoid safety. It's a temperature safety system that is working in concert with the controller and the relief valve to prevent any over temperature condition to the building. And also, I believe, I'm sure that in this installation there's also a blending station on the wall that's not in our scope, that will not allow hot water to get to the facility and maintains the right building recirculation water. So there's 3 heaters. 2 are domestic that I said are SIV8s. There's 1 Zamboni fill unit in another location that's an SIV6. And the only difference between the domestics and the Zambonis is the Zamboni is actually this size heater. This is a 6, okay? And the valve on the Zamboni is a 2-inch valve versus the valves on the domestics, which is 2.5-inch, which are 2.5-inch. Okay. The domestic heaters are each size for 75 gallons a minute at 100-degree rise, 40 to 140, when supplied with 25 pounds of saturated steam. When I did the startup, I was up there in March, I did a startup, there was only 17 pounds of steam. So if you don't give us the 25 pounds of steam pressure, you're not going to have the 75 gallons a minute required capacity per the contract documents. You'll get hot water, you just won't get the full capacity. The Zamboni is rated for 40 gallons a minute at 120 degree rise. Excuse me, I wrote it down here wrong. We're delivering 160 degree water to the Zamboni heater, to the Zamboni fill, I should say. Again, requiring 25 psi steam. In review, we have a 100 degree rise for the domestic heaters, and then it's blended down to the use temperature, and then for Zamboni it's 40 to 160, and I don't believe it's blended down. I think it's going 160 right into the Zamboni machine. When I commissioned the heaters in March, I found that the installation by Johnson & Jordan was impeccable. Everything was perfect compared to the requirements by the manufacturer, and there were no issues. There were a couple of minor things that I brought up in the startup report that I believe was taken care of. So here's what we're going to cover today. We're going to cover the concept of the heater and the construction, the basic features and benefits, the control portion of the heater, the safety aspects of the heater, okay, required maintenance, and what the future looks like. So we're always looking to lower maintenance and try to listen to, nothing's perfect. Everything needs maintenance. This heater is built out of stainless steel and copper. It's a very simple device, but what happens is the brain, we're always trying to maintain a very safe temperature. So there's 3 ways we can control temperature. We can do it with a steam piloted device, which is a 150-year-old concept, works fine. We can do it pneumatically, which also works very well, or we can do it electronically, which is what we're defaulting to today, because the other 2 scenarios are fraught with problems. More maintenance, compressor maintenance. Pneumatics are your fastest and probably the most reliable. It's just that you have that compressor to maintain. Steam piloted devices are fine until the pilot fails, and then you've got a problem on your hands troubleshooting. The electronics are fast today. They're a lot faster. What Colby has been using for the last 12 years or so is now being phased out. And we're going to talk about that. The Amarak, the Warren Amarak controller has been reliable, but not as reliable as we like. So we're always looking for something more reliable, which we have now found, and we're going to talk about that later. So those are the items that we're going to discuss. Let's get right into it. The heater is a semi-instantaneous, and it's called that because the water is in the shell and the steam is in the tubing. So the primary media, the steam in this case, is going into this chest. There's a baffle here. It hits the baffle, goes up the tube bundle and back down, and it comes out of the heater as subcooled condensate. All the other water heaters, steam on-demand water heaters, deliver steam into the heater and deliver steam out of the heater. ACE didn't want to do it that way. ACE wanted to do it more efficiently, so we've added surface area. So we know that as long as your incoming cold water is 100 degrees or less, we can condense the steam to condensate and deliver condensate that is well below the normal temperature, which is 200 plus degrees, going into a trap, flashing into a condensate receiver. It's very energy inefficient. So what we provide for you, Colby, and for other customers is steam comes into this unit, but it comes out as a condensed, subcooled condensate. Subcooled is defined as any temperature below 190 degrees. At 190 degrees and above, condensate will flash back to steam when it's discharged to atmosphere. So we're now delivering condensate temperatures by design of 160. And very often we go much below that. But from a spec standpoint, we can guarantee that the condensate will be delivered out of this orifice here at 160 or below. That's the good news. It's highly efficient. It's very unique. It does require more surface area. It does require heavier wall tubing because when steam hits condensate, it's a little bit violent. So basically you have a U-tube. You got a picture of a U-tube bundle that comes up to about here. Okay, so the first pass is steam. The back pass is what they call two-phase flow. It's steam, it's condensate, it's very hot condensate, it's flashing the steam, and it's two-phase. It's steam, poor quality steam, and high temperature condensate. So we're holding back the exiting of this condensate with an orifice in that union. Okay, there's a brass orifice in this union, which is acting as a simple steam trap, what we call a simple steam trap. It's not a Venturi steam trap, don't confuse that. This is just a dam to hold the condensate from leaving the heater so the incoming cold water can take that 200 plus degree condensate and wring the BTUs out of it. Take all the heat out, and it just makes for a much more efficient device, and it saves your condensate receivers from flashing, steam, pitting the impeller, cavitating the impeller. It's a great device. It's a great design, and there's no moving parts. Nothing will fail. I will tell you there's a downside to this feature, is that when your condensate comes out of this heater, there's no pressure. So you cannot lift the condensate and get up into a condensate line that's above the invert of that outlet. We want to go by gravity to a vented receiver or to a gravity line that is below this elevation. So very often if we have a problem with elevation height, we can take this heater and lay it down and make a horizontal heater out of it so we have more drop. We want to have a good pinch. There's a vacuum breaker here that allows that condensate to flow out of the heater. Okay, so to a subcooled device. So the shell of this unit under this insulation, and there's an 1.5 inch of insulation here, is 316L stainless. It's passivated, so it'll stand up well to certain chlorides that are in the system. If you have very high chlorides in your water, you have to tell us that, because we can treat this stainless differently to handle high chlorides. Most people's applications are not that high chloride. So the 316L stainless works very well. These are all these are 304 stainless connections. The new heaters, this is an older heater, the new heaters are now flanged. They're 150-pound flanged inlet, cold water inlet, flanged cold water out, hot water outlet, excuse me. Okay, so you've got steam in, condensate out, you've got a vacuum breaker here, you've got a steam pressure gauge that is here with a siphon tube. The purpose of that gauge is if you see pressure on that gauge, sustained pressure, that means you've got back pressure in your condensate line, and that's bad news for this heater. So we put that pressure gauge there for maintenance purposes. Cold water in, as I said, hot water out. This is an anticipator loop. This pump runs 24/7 all the time. It's a stainless steel volute, copper loop. It's a 1/25 horsepower motor. It puts out 12 gallons a minute at 15 feet ahead. Its job is twofold: to keep the water always washing over the temperature sensor. This is your temperature sensor here. We need water always washing over that sensor so we know exactly where the temperature is, or it needs to be. So as the load changes, we want this sensor to pick it up right away. And if this pump doesn't work, we're not going to have good temperature control. We'll talk about that when we get to the maintenance part, but if you lose this pump, you're going to have very poor temperature control. This pump is critical. It runs all the time. It's designed to run all the time. And that maintains a very, very tight, what we call anticipatory temperature control on the heater, or for the heater. Because the good language in from this RTD into this microprocessor controller, if you have good language in, you're going to have very good language out to the actuator, and you're going to have very tight temperature control. So, heater, connection, accessory items, pump, which by the way, we use now a Taco 007 pump. You can use a 005. I've had situations where people have had very, very hard water, very high grains of hardness, and the 007 runs so much, too much velocity, and they wear out some of these elbows on the pump circuit. If that's happening, just drop it to a 005 and you'll be fine. ASME relief valve on the heater. This is only a pressure relief valve. Excuse me. It is not a temperature and pressure relief valve. It doesn't need to be by the ASME code, because there's no direct fuel being fired here on this. It's the TMP relief valve's on the boiler. This only has to be a relief valve, which is set for 150 pounds or higher. We can go higher. For Colby, it's all 150 pounds. This is your temperature gauge, your water gauge. Okay. Now you got two ways to read temperature here. This is your actual. The green is the set point temperature, what we set for. This is the actual water temperature, and this is just a mechanical temperature thermometer reading temperature as well. What you're seeing here is a solenoid, an ASCO water solenoid. It's a two-way solenoid, and its job is to discharge the water into an indirect waste in the event something happens. The temperature control runs away. Something happens. We don't want the relief valve discharging if we can help it. We want to dump the hot water out of the heater. The cold water comes in, the heater resets, and then you get an annunciation at your building management computer saying, heater in building, the athletic center tripped, go check it out. So what we have here is a very smart control panel. We use a controller called the Shiminin controller. We've used it for over 20 years. Very reliable, very simple, easy to understand. The letters are actually big enough to read for old guys like us. Okay, the buttons are big enough to push. And I know Tom and his team are very familiar with this controller. We've had almost no problems at all. If you get a lightning strike, it might burn up the controller, but other than that, we've had very little problem with the controllers. We're going to go through the controller in a minute, but what this controller does is reads the water temperature, as I said, and then puts out a 4 to 20 milliamp signal to this valve actuator. Okay, so there's two conduits going into this valve. You've got power, which can be either 115 or 24 volt, and then we have the output of this controller, which is 4 to 20 milliamp going in as well. Okay. What else? That's pretty much it for the components. Safety, solenoid, feedback. All right, let's talk about the Shiminin controller at this point. This is the brain, and brains get fooled with. Okay, people like to tweak things, but we like this controller because we can set it up as I might not have said it, but this is a PID, proportional, integral, and derivative type controller. Okay, that gets a little bit out of my pay grade, but we set those parameters up when we set up the heaters. We don't like to just let the contractor start the heaters. Not that they can't, but every situation is a little bit different. But let's go through the controller settings real quick. They're really basic. There's two screens. What you need to be aware of is really the first screen. The first screen shows the set point temperature, in this case 120. The actual water temperature in this case is 121. We're not actually filled with water here. We're running off a calibrator. The left button, there's left buttons, there's a left button, the right button, and up and down buttons. If you push the left button one time, it goes from set point variable to the output of the controller. This is showing 38.2% of output to the controller. Okay, it's not telling the valve to go to 38% of its CV. It's just saying this is what the controller is putting out. That's the first screen. The second setting. We don't use, this is standby. We don't use this. We don't use the auto tune. 18 means auto tune. This is a very important one. The fourth one is very important. It says E1HD. It's an emergency dump for high differential. If you notice, we're setting here, the E1HD, we're set at 30 degrees. So, our water temperature is 120. This heater will trip and shut itself down at 150, 30 degrees over the set point. We can change that. We can lower that to 20. We can raise it. It depends on the application. And we're going to demonstrate later how this will trip. And the green light will go to red. You'll get an annunciation in your panel. The heater will shut itself down and turn itself back on, hoping that a piece of dirt got under the seat of the valve, and that by shutting down and opening wide open, it will flush itself clean and it'll go back to normal. So you show up in the mechanical room and there's water all over the floor and the green light's on and everything seems fine. It's probably because a piece of weld slag or something got under the seat and it just was bleeding BTUs when you had no load on the heater. This is common. Okay, we're going to talk about what happens if that valve leaks by, that control valve. They're not bubble tight shutoff. Okay, they're what they call class 4 shutoff. So on a weekend or a holiday, if there's nobody in the dormitory or nobody using any hot water, if excuse me, that valve will bleed by a little bit of steam. What we insist on is to have in your building recirculation system, which is outside of our scope, it plugs into the heater here or in the cold water line. You have a building recirculation pump, must be running all the time. If that pump is triggered on an aquastat or shuts off, we run the risk of this heater going into over temperature. Very important. And I think that Colby leaves their heaters on. A lot of years ago, people would run those building recirc pumps on an aquastat, or they try to save energy by turning it on low speed, and there's not enough flow going through the heater to radiate away that little bit of leakage on your valve. So that's a potential problem that I'm sure Tom can talk about even more so. Okay, so the 4 settings, the 4 screens. First screen is your normal screen, set point variable, actual water temperature. That's the output of the controller. We don't use standby, we don't use auto tune. That is set by us and locked, high differential. Okay, and so if you change the temperature on this heater,